Welcome to the third video where we will be continuing to look at the solutions from this year's trial exam. So picking up with question 24, we've got a timber log of length 2.4 metres and a diameter of 90 centimetres. It's been cut in half, producing a semicircular section as shown below. What is the surface area in square metres of this semicircular piece of timber, correct to 1 decimal place? Now, hopefully the first thing that we notice is that our length is in metres and our diameter is in centimetres. We want an answer in square metres, so the best thing to do is to convert our 90 centimetres into metres. Centi means 100, so there's 100 centimetres in a metre, so that 90 centimetres is 0.9 metres. Now that all of our measurements are in the same units, i.e. metres, we can actually proceed. So let's look at the areas that we've got. So we've got this area on the front, let's call it area 1, and we've got the area on the back, let's call it area 2. Both of those are semicircles, which means if I add the two of them together, I'm going to get one whole circle. So let's start off by that. So area 1 plus area 2 will be the area of a circle, which is pi r squared. Now our diameter is 0.9 metres. So half of that will be our radius. So our radius is going to be 0.45 metres. So we can plug that in. So pi times 0.45 squared, putting that into a calculator, we get that the areas of area 1 and area 2 combined would be 0.636 metres squared. So that's the front and the back of our semicircular log. There are two other areas that we need to consider. We have this area on the top, and this is the one that most people forgot to include. Now, I'm guessing that it was the diagram was a bit misleading, so that you thought that it was actually like a trough, it was hollow on the top. Not the case, there is an area on the top that we need to include. So that's just a nice rectangle. So it's going to be length times width. So our length is going to be 2.4 metres and our width is going to be 0.9 metres. Plugging them into a calculator, the area of the top is 2.16 metres squared. Now our other area we have to consider is our curved area. All right, this is the bottom part, half of our log section. So what is that particular thing? Well, it's a cylinder realistically. Area of a cylinder, the curved part of it, is 2 pi r h, but we've only got half of that, so it's going to be a half of 2 pi r h. Well, a half times 2, they're going to cancel each other out, and we're left with just pi times r times h. Well, we know our r is 0.45, and we know that our h is 2.4. So I can just multiply those three things together, and we get that the area of the curved section is 3.393 metres squared. What then is our total area? Well, we just want to add those three numbers together. So we're adding 0.63, 2.16 and 3.393 to get that the total surface area is 6.2 metres squared. Surface area is never a simple formula. It's always a case of having to work out all the individual areas and add them up. Question 25, we've got a total of $11.60 being charged for 29 days interest calculated on a credit card balance. If the bank has an annual credit card interest rate of 18.25%, what was the credit card balance when the charge was calculated? All right, so we know that we've got $11.60 that's been charged for interest over 29 days. So we need to work out how much were we charged per day. Well, it's just going to be $11.60 divided by 29. We've been charged 40 cents interest per day. So what then is our daily interest rate? Well, we know our yearly interest rate is 18.25%. So we're going to have to divide that by 365 to work out what our daily interest rate is going to be. We know we've been charged 40 cents per day, but what was the actual interest rate? Well, when we do that, what we're going to get is 0.05%. So then how can we work backwards now to work out what our credit card balance was? Well, we can work out our interest based on what our balance was. So if we wanted to work out our interest, it would be the balance times the interest. So whatever our credit card balance was times the interest rate of 0.05% would give us our 40 cents. Now, 0.05%, we're going to need to convert that to a decimal. So to convert it by a decimal, we're going to divide it by 100. So then that's exactly the same as saying 0.0005. So our credit card balance times that 0.0005 would equal 40 cents. So now I'm going to divide both sides by that 0.0005. When I do that, on the left, I'm just going to be left with the credit card balance. But on the right, when I do this, I'm now going to be left with what was our balance. So 0.40 divided by 0.0005 gives us an original credit card balance of $800. Question 26. A manufacturer outlays $60,000 for a machine which produces a part for jet engines. The graphs representing the manufacturer's costs, C, and the income, I, from the sale of those parts are shown below with their respective equations. Part A, at the break-even point, how many parts are sold? Well, first thing we need to hopefully identify is what is our break-even point. We should all remember that that's where our income and our costs are exactly the same. So if we look at the graph, we can see where those two lines cross, and those two lines cross where I equals C. And where does I equal C? Well, that's going to be where our costs are $80,000. Hopefully you can see that's where those two lines cross. So we know that I is 20N, that's given to us. And we know that C is 60,000 plus 5N. So I'm just going to say that those two things are equal. 20N equals 60,000 plus 5N. So then what can I do? Well, I've got to take away my 5N, so I've got all my N's on the left-hand side. Take 5N from both sides, we're going to have 15N equals 60,000, because I want to get to 1N. What is 1N going to be? Well, it's going to be 60,000 divided by 15. 60,000 divided by 15 tells me that N is 4,000. So this graph was nice. We could read that it was 80,000, or it looked like 80,000 was the cost, but we didn't know what the number of parts sold were at that break-even point. Now, we could just assume that that 80,000 was correct and go then, well, our income is 20 times N. So 80,000 equals 20 times N, divide both sides by 20, and N is 4,000. The only problem with that is if the graph doesn't nicely show us that it was 80,000. All right, we could have done it in this instance, but that will not always be the case. So for part B, what profit is made per part when N parts are sold? So we can see N with the dotted line that goes up. We want to know what's the profit that's sold. So what's the gap between our cost line and our income line? Now we can nicely read off the graph that our income when we sell N parts is going to be 120,000. We can't really read off what our costs are going to be. It looks like it's between 80,000 and 100,000, so it could be 90,000, but it might not be. But realistically, that's what it looks like. So what we want to work out firstly is, well, how many parts have we sold? So we know that like I said before, our income is 20 lots of N, and we know that that's 120,000. So 20N is equal to 120,000, so we divide both sides by 20 to get that N is 6,000. All right, so we're selling 6,000 parts. So then what's the profit that we're making at that point? Now we could plug 6,000 into both of those two equations for N to work out what our income was. Well, we know that's 120,000. Put it in there to work out what our costs are. 5 times 6,000 is going to be 30,000. 60,000 plus 30,000 is 90,000. So luckily, yes, our costs are exactly halfway between 80,000 and 100,000. So then if we've got $120,000 as our income, and we take away our $90,000, which is our costs, that's a difference of $30,000. So that's the total profit that we have made. The question says, what's the profit per part? All right, profits made per part when N parts are sold. So we've made $30,000 on 6,000 parts. So I want to divide my 30,000 now by 6,000 to work out that I've made $5 profit per part. Question 27. A new drug study was conducted with 80 people chosen at random to determine whether taking vitamin A or vitamin B over a period of 2 months had any significant effects on lowering cholesterol levels. Right? Cholesterol is bad, it's in our blood system, we want it to be low. So here we've got a couple of drugs that are reducing cholesterol. Right? Several people made the assumption that cholesterol was good and we wanted to have more cholesterol. That's not the case. Right? We're talking about lowering cholesterol levels. Right? It tells us that straight up. So it doesn't matter if we know that cholesterol is good or bad. It says we just want to lower them. So that's what we want to look at. 40 people were given vitamin A and the other 40 were given vitamin B. All 80 people recorded cholesterol between 8 and 10 before the study. So before they took either vitamin, they had a cholesterol level between 8 and 10. The diagram shows parallel box plots with the results of the study from the two groups, vitamin A on the top and vitamin B on the bottom. By comparing the differences in the presented data in terms of central tendency and spread, what conclusions can be made about the effectiveness of the vitamins in the study? Now it's 3 marks, so straight up you should hopefully realise we want 3 statements. Right? We want 3 things that we can pull out from that particular graph. So hopefully we can look at it and see, well, vitamin B overall has numbers that are lower than vitamin A. There is an overlap between the two, but vitamin B is lower down. All of the results are further down towards 0 than with vitamin A. We need to do some sort of mathematical way of saying that. So what have we got? Well, if I put in this line here at 8, right, remembering that all of our initial people had levels between 8 and 10, what can we say from that particular point? Well, 75% of the people, which is going to be 30, in Group A had their cholesterol reduced below 8, whereas 100% of Group B, all of them have had their cholesterol lowered to below 8. Right, so just by looking at where they all sit, all of vitamin B are below 8, and we knew, like I said before, that they were between 8 and 10, so they've all been reduced, whereas with vitamin A, there are still people sitting at 10. So that says to me that those people in vitamin A who are still sitting at 10, they've got no effect from taking vitamin A at all. Whereas everyone in Group B had a positive effect. They've all been reduced. So what else can we see on this particular graph? Because that's one statement that'll give us 1 mark. So if I put in a dotted line there, what that tells me is if I look at vitamin A, 25% are to the left of that line, but 75% are to the right of that line. 50% of the group are between the 2 red lines. So 25%, or 10 people in Group A, have had their cholesterol reduced to below 6.5. That's assuming that that's exactly between 6 and 7, that line. So 25% of Group A are below 6.5, whereas when we look at Group B, it's more than 75% are below that line. All right, so we can tell straight away that vitamin B have had most of their people below 6.5, whereas with Group A, only a quarter of the people are below 6.5. So that's 2 marks that we could have possibly gotten. Now let's put in these lines here. What these are showing us are the medians of each group. So vitamin A, the median, the middle score, is roughly 7.5, and with vitamin B, it looks like the median score is around 5. So we can say that the median of Group A decreased by a smaller amount than the Group B median. Now, remember it said that everyone was between 8 and 10, so we could assume for both groups they had roughly a median of around 9. So that median of 9 for both groups, for vitamin A has dropped down to 7.5, but for B it's dropped down to 5. Now we can't say it was 9 because we didn't know where it was, but we can assume it was somewhere between 8 and 10. If they were roughly the same, vitamin A's one has moved down less than what vitamin B has moved down, right? So vitamin B has had more effect. Another thing that we can say is that Group B had a much lower minimum cholesterol level, right? Our minimum score for vitamin B was 3, as opposed to our Group A. Vitamin A minimum looks like that's around 5. Right, so Group B has had a greater effect because everyone was between 8 and 9. So let's assume for both groups had someone on 8. The person in Group A who was on 8, who has now dropped down to 5, has had their score lowered by 3. However, the person who was on 8 in vitamin B group has had their score almost dropped by 5. to get down to 3. Right, so vitamin B's had more effect on our lowest score. Overall, we can make the statement that vitamin B must therefore be more effective. Now, I gave you 4 different statements there. You didn't need to use all 4. But you needed to pick something out from those 4 statements, though, that you wanted to use. Right? The point being that we can show that vitamin B is more effective. Question 28. A radial survey has been undertaken on a proposed construction site labelled QRST as shown in the diagram. The section PRS, which is shaded, of this particular site is going to be proposed use as a car park. We want to use the cosine rule to determine the distance between S and R of the car park. Now, this question is nice and easy in the sense that it tells us to use the cosine rule. Right? It could have been a lot harder by just saying find the distance from S to R, or the length of the line segment SR, however they want it to be worded, but they've nicely told us to use the cosine rule. So that's straight off our summary sheet, formula sheet, reference sheet, whatever you want to call it. C squared is equal to A squared plus B squared minus 2AB cos C. Now we want to find the length SR, so SR is going to be our C. Doesn't really matter whether we use 25 as A or as B, because the other one's going to be 40, so it doesn't really matter. So we know that C is going to be SR. A, or let's use PS on the left, and then we'll use PR for B on the right. So then it's going to be minus 2 times PS times PR times the cos of that angle across from the side length that we want, SPR. So we need to find out that angle. That's the piece of information we don't have. Now we know from the fact that R says 140, that's our bearing from north. So that means that that red angle there is going to be 140 degrees. Other piece of information we've got is that angle, or point S, is on a bearing of 260 degrees. So that means that that big blue angle there is 260 degrees. So how can I find just the angle of the shaded section there? Well, it's the difference between those two angles. So it's going to be 260 minus 140 degrees. And that tells me that that angle in the middle there, SPR, is going to be 120 degrees. So let's just mark it in there in green. So there's our angle of 120 degrees. So now I can put that in for SPR. So SR squared is going to be 25 squared plus 40 squared minus 2 times 25 times 40 times the cos of 120 degrees. Now I can just plug that straight into my calculator and it comes back telling me that SR squared is equal to 3,225. That's SR squared. We don't want SR squared, we just want SR. So we're going to take the square root of both sides, and that tells me that the length from S to R on my shaded triangle is 56.789. Well, that's almost 57, so let's just round it to 57. So we can say that the distance between S and R is 57 meters. Right? All of our units are in meters here, so we can round that to 57 meters. That was part A. Part B, if angle TPQ is 80 degrees, what is the bearing of T from P? So we want to find the angle TPQ is starting at the top T, coming down to P and going up to Q. So that's that bit in the middle, it's that top triangle, right? The angle there at the bottom of that triangle is 80 degrees. That's what we're told, right? If angle TPQ is 80 degrees, what is the bearing of T from P? Well, we know that from north over to Q is 65 degrees because it tells us its bearing is 065. So that blue angle in there is going to be 65 degrees. So what then is the other angle from the north over to T? Well, it's going to be the difference between 80 and 65. So that's going to be 15 degrees, that orangey angle in there. So how does that help us? Well, what we want to know is what is the bearing of T from P. So if I start at north and I go all the way around to T, that's going to be our bearing. So we want to find what is this green angle. Well, we know in a circle we have a total of 360 degrees. We're not doing a full 360, we're doing 15 degrees less than 360. So 360 degrees minus 15 degrees is 345. So my green angle there, angle NPT, is going to be 345 degrees. So what then is my bearing of T from P? Well, it's going to be on a bearing of 340 degrees T. T is true, right? That's our true bearing. We could have said, because it didn't specify what sort of bearing, we could have said, well, it's going to be north 15 degrees west. We could have said that as well. That's the exact same answer. But because everything else is given to us as true bearings, we're going to stick with true bearings. And that brings us to the end of video number 3 of the 5 videos where we are going through the solutions for this year's Mathematics Standard 2 trial exam.